Okay folks, welcome to this video. We're looking at 0654 Winter 2021 question paper 4.1 and we're looking at question number 9. Now I've got on the left my model answer here. We've got the mark scheme up in the top right and then we've got slightly out of proportion my big ugly face. If you've got any questions folks, please post them in the comments below about physics or about the questions in general. I'm more than happy to help. Okay, let's get started. We've got a raft. Okay, and it is filled with air, and we're being asked to describe how the motion of the air molecules cause pressure. Now, this is one of the kind of standard questions in a question about thermal physics, just about how we get a pressure. And really the points that you're looking for is as follows. The idea that when we have gas inside a container, for example, this could be my wall here, those gas particles are colliding with the wall. They're bouncing off the walls, and that will then create a force. Okay, now if you see the mark scheme, that's exactly what we're going for here. We need to have some indication of the fact that you've included something about the collision of molecules with the wall, and that each of those collisions produces a force. And so it's actually really important you explicitly state that. Have a look at my answer. The molecules collide with the walls of the rubber tube, and each collision produces a force. Okay, so we're not looking for bullet point answers here, but we're looking for something which conveys kind of what you should know at this stage. Okay, so that's our kind of settler. All right, we're having collisions with the walls. Now, key point there, just before we move on, is that we're not looking at collisions between the particles themselves. We're looking at collisions with the walls. All right, because the collisions with the particles themselves don't contribute to the pressure. Okay, next question. We're told that as the sun warms the air up, the pressure increases, and explain why. Nice and sort of hopefully straightforward answer here. As soon as we see the sun warming things up, we need to think about temperature going up. Now, as I hope you remember from your lessons, when the temperature increases, the molecules have a greater kinetic energy. And it actually leads to two things here, and we'll look at one of them from the mark scheme. Okay, we've got faster moving molecules, and that means that we're getting more and more collisions. Well, obviously, if we get more and more collisions, we're going to get a greater force, and therefore a greater pressure. Okay, and so therefore, that's the kind of CIE answer. Now, there is another answer here, which is slightly more advanced, but equally valid, and you could go for both here, in my opinion. Okay, would be that each of those collisions produces a greater force. Think about it. If you're traveling very, very quickly and then you hit into something, you're going to exert a greater force on the object you're hitting. And so therefore, we have not only more collisions, but stronger, more forceful, higher force collisions, which are both leading to a greater pressure. Now, in this case, the mark scheme talks about more collisions. Go with that then. Okay, but just remember that there are alternative ways of explaining these things as well. Both explanations would be valid. Okay, let's crack on. Okay, we're then asked to calculate an area. We're told the weight of the raft, and we're told the pressure. Now, this is quite a sort of different question because we're not often asked to calculate areas. Usually we'd be asked to calculate maybe a pressure here. But actually, the questions tip things on its head a little bit, and this is where any of our tools can be useful. Okay, I've drawn the triangle here, F on the top, P and A. Remember, triangles don't always work for every equation. It's just helpful for this one in particular. And I've said forces push areas. Okay, well, if we look at our triangle, F equal to PA, and so there, if A is equal to F over P. Now, you might be wondering what this F is. Well, remember, weight is a force, and I think that's where students kind of struggled with this question. We forgot about the fact that the weight is a force, and you can see that because it's got the units newtons. Now, you may have kind of got a bit confused at this stage and thought, oh, I don't know the weight. Well, I don't know the force here. Well, the force is simply the weight, okay? And you're expected to be able to juggle between those two. From there, it's fairly simple. 1,100 divided by 500, 2.2. Nothing wrong with significant figures here, and we're going to have an area of 2.2 meters squared. Remember, we want to see some working, and we want to see the correct answer as well. Last one, and a little bit tricky, this one. The tide causes the raft to move at a certain speed, 4 meters per second in this case. We're asked to calculate the kinetic energy. Now, we know the kinetic energy equation, hopefully, that EK equals a half mv squared. Now, I struggle with coming up with a mnemonic for this one. I find it really hard to come up with that. I have it ingrained in my brain. Okay, one way you could, and it's a horrible one really, kinetic energy means m, you half to travel very v fast squared. Not so happy with it, but it'll go. Okay, E equals a half mv squared. Now the tricky bit here is actually we don't know the mass. Okay, we know the weight. But what we have to do is invoke another equation, which is the idea that weight is made by gravity. W equals to mg. In other words, m equals to w over g, mw over g. And then we've got a mass of 110 kilograms. So in the question, they didn't tell us the mass. We had to work it out using one of our equations, and we then used that value to calculate kinetic energy. Okay, now if you look at the mark scheme, there is a mark for saying 110 kilograms. Okay, now whether you needed to work that out or you could just identify it, it's a GCSE level question. I would calculate it, show you know why it is 110 kilograms rather than just saying it is. And from there, you can put in your half, 110 for squared, remembering to square there, and getting 880. Now the common problem students would have here would be missing that point about the weight and simply putting the value directly in and getting a value too big. Well, that would lose you 1 mark here, okay? Another problem students would have is to forget to square. Now that is a really important one, and again, that would cost you a mark. Okay, so make sure you are just checking those equations. Okay, last one, what causes tides? Now I don't like this answer to a question, the moon. All right, now, that's a really base level answer. Okay, really what's causing the tides is the gravitational pull of the moon and the gravitational pull of the earth, etc. Okay, it's not as simple as that. We don't just have tides because of the moon, okay? But this is what CIE went with this time. If you see this question, you could be, as long as it's a 1 marker, you'd be fairly happy with saying simply the moon, okay? As long as you give an explanation of how the moon is involved in this process, then that should be enough. Okay, well done for watching this and checking your answers. Obviously, you can pause this at any point to look at the mark scheme, to look at my answers, to see how things go. And as ever, please do let me know if you've got any questions. More than happy to help. Okay. If you'd like any more updates, hit the subscribe button. That will allow you to get these straight away. Okay. All that remains for me to do is to wish you all the best for your revision and to encourage you to watch another video. Bye-bye.